Okay, you're welcome to another physics lesson. I'm still your physics teacher, Mr. Moses. Welcome. This time we'll be looking at equilibrium of forces. Equilibrium of forces, that means how different forces acting at a point or on an object tend to balance themselves. First, we say a body is said to be in equilibrium when the body as a whole either remains at rest or moves in a straight line with constant speed. Defining equilibrium, if an object is at rest, it means that all the forces acting on the object are balanced, they are equal. And then if an object is moving in a straight line at constant speed, it means that the forces acting on the object are equal. That means there is no increase in speed, there is no decrease in speed. Whatever force is acting on it is at making it be at equilibrium. We also say that a body is said to be in equilibrium when the whole body remains at rest or moves in a straight line, for like the example we have above. The car is moving at constant speed. It is not accelerating, it is not decelerating. So the force acting on it is said to be equal, so the body is in equilibrium. Equilibrium is also seen in rotating objects. If an object is not rotating at all, that means it is still, like we said before. It means that it is in equilibrium because the forces acting on it are equal. And when it is rotating, if it does so at constant angular velocity, then the force acting on it is also at equilibrium or is equal, like the example you see above. When an object is stable or resting on a particular surface, the two forces acting on it are the weight of the object and the normal reaction from the surface. That means one of them is acting downwards, one of them is acting upwards. So it is said to be at equilibrium. Then we go to types of equilibrium. We have static equilibrium. Bodies in equilibrium at rest are said to be in static equilibrium. If the object is at rest, we have said before that it means that the object is in equilibrium or is in a state of equilibrium. So this state of equilibrium is called static equilibrium. It means all the forces acting on it are equal. And then the second type of equilibrium is what we call dynamic equilibrium. Bodies in motion either on a straight line or rotating about a fixed axis at constant speed are said to be in dynamic equilibrium. So equilibrium by different forces acting on an object can be achieved either when the body is at rest or when the body is moving. But when it is moving, it has to be in constant velocity. These are two examples. The one on the left is static equilibrium, where the two objects balance each other. In this case, the weight of the object is what we are considering. They balance each other and they are static. In the second example on the right, the girl is moving upwards and the staircase is moving downwards. So in this case, she's moving at constant velocity and she is balanced. Then we move to resultant force. The resultant force is that single force which, acting alone, will have the same effect in magnitude and direction as two or more forces acting together. We have just said that when an object is at equilibrium, two or more forces are acting on it and those forces are in equilibrium. Now resultant force is saying it is the result of two or more forces acting on an object or at a point, like the example above. F1 and F2 are two forces acting at a particular point in different direction, while the resultant force, as you can see, is the effect of the two forces. The effect of the two forces is what we can see there. That is the resultant force. And then we have force addition still under resultant force. The resultant force can also be described as the addition of the two forces or all the forces acting at a point. When the forces are in the same direction, you add them together as you can see above. When they are acting in the same direction, you add them together. When they are acting in opposite directions, you subtract them, as you can see in the diagram above. So the resultant of the first one is 20 Newton and the resultant of the second one is 0, meaning that the two forces cancel each other out. And then when the direction of the two forces are at an angle 90 degrees to each other, the resultant or addition of the two forces is gotten through the Pythagoras theorem, as you can see in the diagram above, where the hypotenuse is the resultant of the two forces. And then when the forces are at angles that are not 90 degrees to each other, the formula below, which is called the cosine formula, is what you use to get the magnitude of the two forces. Hence, the resultant is determined by any of these, which is also the addition of the two forces, to get a general effect of what the two forces acting on the body will give. And then we have what we call the equilibrant force. The equilibrant of two or more forces is that single force which will balance the other two forces taken together. It is equal in magnitude but opposite in direction to the resultant force. We just explained the resultant force as the addition or summation, the sum effect of two or more forces acting at a point, the result of the two forces, as you can see. Now the equilibrant is the opposite of the resultant. It is what balances the resultant. Yes, the equilibrant is what balances the resultant. It has the same magnitude as the resultant, but it is opposite in direction, as you can see in the diagram above. As you can see in the diagram above, it balances the resultant. And then we go to triangle law of forces. Triangle law of forces. Please note that everything we are saying has to do with balancing of forces to cause equilibrium on an object. The principle of triangle of forces states that if three forces or vectors acting at a point are in equilibrium, then they can be represented in both magnitude and direction by three sides of a triangle taken in order. What this means is that if three forces, we have been showing pictures and we have been dealing with two forces acting at a point. If the forces acting at a point are three and they are making that point to be in equilibrium, either the point or an object to be in equilibrium, then it means, or it is said, that those three forces, like in the diagram above, can be drawn in the same direction as they originally are, but to take the shape of a triangle, as you can see above. If the three forces are in equilibrium, then you can draw them to take the shape of a triangle, such that the length of the force is equal to the magnitude of the force and the direction remains the same direction as it is in the original diagram. As you can see here above, the directions do not change. We just rearrange them to form a triangle. So if the three forces acting at a point are in equilibrium, then they can be rearranged to form a triangle. This is another example of the triangle of force, as you can see. Here we have F1, F2, F3 rearranged, so that when we are now looking for the forces, we can now look for them and deal with them as though we are dealing with the sides of a triangle. So it's either the triangle is right angle triangle or any other triangle, depending on the direction of the force. Thank you very much. Please do well to answer the questions in the portal. Thank you.